Hello there and welcome back for another Advent of Code video. So I'm a little bit behind the puzzles. I just finished, today I finished solving day 12 and it's almost day 15, so let's get back to it. I really hope that the next one is not as difficult as day 12. I have a giant font size here, but look at that drawing. Nice. Now the gear island really looks like a gear, and I guess this should be the giant metal springs that we used in the last puzzle. I really like the shape of this. Okay, let's see what day 13 is about. Lucky number. Point of incidence. With your help, the hot springs team locates an appropriate spring which launches you neatly and precisely to the edge of Lava Island. Nice, neatly and precisely, very nice. There is just one problem, you don't see any lava. You do see a lot of ash and igneous rock where there are even what looks like grey mountains scattered around. After a while, you make your way to a nearby cluster of mountains only to discover, that the valley between them is completely full of large mirrors. Okay, it looks like another grid-based puzzle. Those are usually nice, although I don't know, the puzzles on this Advent of Code so far, some of them have been really challenging, I think. So I am a bit scared already. Oh man, how scared I was when I ran the previous, like the day 12, like when I finally got something working, I was like, I don't know, it felt like finally defeating a very powerful enemy on a video game or something. Okay, we are in a valley full of mirrors. Okay, most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction? As you move through the valley of mirrors, you find that several of them have fallen from the large metal frames keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Maybe the terrain is because the terrain is all one color, it's hard to see whether it's safe to walk or whether you're about to run into a mirror. You note down the pattern of ash, dots, and rocks. Hash symbols. This is giving me flashbacks of the previous puzzle that you see as you walk, your puzzle input. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. For example, here we have, I guess, two different patterns of this. To find a reflection in each pattern, you need to find a perfect reflection across a horizontal line between two rows or across a vertical line between two columns. Okay, so it seems like at least here I can see sort of a reflection along this line. And there's another one here, I think. I'm not sure. In the first pattern, the reflection is across a vertical line between two columns. Arrows on each of the two columns point at the line between the columns. Okay, so this is the first pattern, and I guess the reflection is here between two columns. But there's one extra column here that is not mirrored in this side. In this pattern, the line of reflection is vertical line between column 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, column 1, has nowhere to reflect onto and can be ignored. Every other column has a reflector column within the pattern and must match exactly. Okay, column 2 matches column 9, column 3 matches 8, 4 matches 7, and 5 matches 6. Okay, so far so good. The second pattern reflects across a horizontal line instead. Okay, I think this is what I saw here. I guess the horizontal reflection here Yeah, look, there is an extra hash here that is not here. I don't know if I'm calling this hash signs, but I think they are also called like pounds or tic-tac-toes. I don't know, different names for those. So in this one, they are reflected on like horizontal reflection. Okay. Or reflects across a horizontal line between rows 4 and 5, or row 1 will reflect with a hypothetical row 8, okay, but since that's not in the pattern, doesn't need to match anything. Okay, I guess it has to match perfectly, but some rows and columns can cannot have a reflection if the line is like not perfectly in the middle, I guess. Okay. To summarize your pattern nodes, add up the number of columns to the left of each vertical line of reflection. To that, also add 100 times multiplied by the number of rows above each line of reflection. In the above example, the first pattern vertical line has 5 columns to its left, and the second pattern horizontal line has 4 above it, a total of 405. Okay, yeah, find 100 multiply, okay, fine. Find the line of reflection in each of the patterns in your nodes. What number do you get after summarizing all of your nodes? And the inputs, and it's like we have many patterns. Look at this. Some of them are like visually we can see the reflection sort of. So I am wondering a couple of things. There's a like sort of fake horizontal reflection in here, I think. Okay, yeah. This is weird, right? The input. I wonder if part 2 will ask us to like stitch this pattern somehow. That would be a difficult part 2. I wouldn't be surprised, to be honest. I am guessing that all of the reflection lines are across, like between 2 lines, between 2 rows or 2 columns, and it's never like a column like this, and then these 2 would be reflections and so on. I hope that is the case. But okay, let's jump into the code and see. So let's go and open the code editor. Oof, day 12, hot springs. Damn, this was such a challenging puzzle. I'm glad that I got it working, but man, it was difficult. And it's not the first difficult either. What was day 10? Yeah, pipe maze was, yeah, part 2 was brutal too. Damn. And actually, like the actual solution is not too long. Look at this, it's less than 100 lines, but it took me, like, I don't even know if I will upload the videos solving this thing, because they are like 3 sittings of 2 hours, almost 2 hours each, and so like 5 or 6 hours of just suffering through this to only do like less than 100 lines of code. So you know, if you feel like non-productive at work or something, it's like, yeah, sometimes this happens, you know, when things are difficult, it's difficult to like produce code, working solutions. But yeah, I was just setting a stopwatch to not make this video too long. But I mean, part 1 for this day seems pretty, I don't know, pretty straightforward, I think. How is this called again? Point of incidence. Okay. So a point of incidence. Is incidence written this way? Yes. Okay. Let's also copy the inputs as we always do. Should automate this at some point, but meh. Day 13. Let's close everything else. The input is gonna be all of these patterns, which I'm worried we will have to do something with all of them at once for part 2. Let's not get ahead of ourselves. The sample should be this, and the sample out was 405, if I remember correctly. Yeah. Okay, so how will we go about this? Let's take a look at the actual input. The patterns, like the minimaps of this, are pretty small in general. Yeah, none of this is too big. And this is like a binary thing, right? Can be either dot or hash sign. So that is good. Simple enough. I'm already thinking about optimizing this unnecessarily. Rust Analyzer is throwing some errors. Let's ignore them. Because since these things are so small, like in width and height, we could do like something clever and like parse each line into like each row into like a single column, because with 64-bit did I say color? I mean number. Like with 64-bit numbers, you have 64 bits to put things and to put information, and this is like you could have like 0 0 1 1 0 and so on, and then comparing rows is just comparing integers, which is like super good. Latex workshop requires a reload. Okay, yeah, I don't want to see a notification here, so reload the damn thing. And yeah, there's something with update available. Yeah, man, this thing is software nowadays is like it tries to grab your attention. Okay, so where were we? We have to parse this. Let's not optimize this into just integers of bits. Let's just parse it into the simplest thing possible, which I think I'm just going to use good old two-dimensional vector of what? Maybe bool, or maybe it's just char. Yeah, let's just use chars, why not? This will be the input lines. We're gonna map each line into something, and then we're gonna collect. I think, I don't know if this can fail because I won't be parsing anything. So each line, again, we are going to get the chars and collect. And I think that is all the parsing we need. Great. And now, how are we going to count these things? Oh, no, that is not the correct way of doing this. This would be the correct way of doing this for each one of the patterns. But we have many patterns, so we don't have one grid. Does this thing call it patterns? Let's summarize all of your notes. You note down the patterns of ash and rocks. You see as you walk. Okay. So let's do one more loop over this, and let's say that these are grids. Okay, and let's make this a type alias called, of course, grid. Gonna put the type over there. And instead of doing this, we are going to do this with each like block of input. So we're gonna have the input. We're gonna split the input by double new line, and then we're gonna map each of those to this basically. And let's call it block. Okay. and we are gonna finally collect. And this is not going to be a single grid, it's going to be a vector of grids. Okay. For example, in each pattern, yeah, it calls these things patterns, so let's call it patterns. Why not? And this we can call it pattern here. Fine. Great. So how are we going to do this? Well, we want to, as usual, add up these things. So one thing that I don't know if the description specifies is that, okay, each pattern will have either a horizontal row or a vertical row. Reflection in each pattern. Yeah, there is a single reflection in each pattern. Okay. Yeah, it calls summarization. So let's call it the same way. Say let's answer 1 be patterns. We're gonna iterate them. We're gonna map them into a summarize pattern, passing this thing, and then we're gonna sum all of these things. So yeah, okay. So let's just print this thing. Answer 1. And generate this function. Generate this function. No, generate this function. Summarize. It's summarize with an A. Summarize, of course. And this has a horrible type. Let's make it a grid. And this is going to be the pattern. And it's going to return a number. So let's say it's going to be the column or row multiplied by something. So let's do it that way. You don't like this because summarize pattern. Oh, I didn't. Summarize. Okay. So let's do this in the most like caveman way possible, cave person way possible, which is to just do loops. So let's first try to find. So what is the one that is multiplied by? Okay, it does columns first and then 100 by the number of rows above each horizontal line of reflection. Okay, so let's try to find first the vertical lines of reflection. So we're gonna go for column in. Do we start with 0? I think we can start with 1, right? I think so. Pattern length. So the idea would be, it's not like I want to use one base index, but I have to go from this, like this would be index 0, like in an actual array, but like here, for example, it's like the line of reflection is like after the 0, 1, 2, 3, like the column index 3. So it's after that and before the other. Kind of looks like it to me. And actually, we should go not until the length of this. Gonna go -1. I think. if I'm not mistaken. So if the length is this has 7, so 7th will be this, right? This line. But if we do it like very generically, we might find, like, say it's on the 7th position, but it is because like everything here matches with everything here, but just because there's nothing down here. So I think this is correct bounds. We will see, however. Off by 1 error is the most common thing. So how do we do this? Well, I think let's do it in the most trivial way possible. So we want to, it's like, okay, I want to see, is the line of reflection here, or is it here? Is it here? Like, try to find when it reflects or vertically across a horizontal line. So we're gonna have like a nested loop, I think, right? And we're gonna go. Let me think. Oh, an interesting thing is about these patterns is like they can't be, like, this line cannot be equal to this line, because otherwise we could also consider this a line of reflection. So that's also an interesting thing, but okay. So what do we want to do here? We want to like go increasingly. We want to sort of zip the lines, like we want to zip this one with this one, and this one with this one, and so on. So that's kind of what I want to express. How do we express this? Well, let's say with two indices that move together. Let's break it in two parts, and let's say let lines below, which is the one that's, or rows below, make an iterator out of this. Here let's return nothing, just so it doesn't complain. The rows below, expressed as an iterator, should be just simply pattern starting at column and onwards, and just iterate over this, and therefore the rows above should be the pattern starting at starting at the beginning and ending at column, right? Yeah, that makes sense. Iterate these things, but in reverse, I think. And so then we should just say, well, above and below, okay? And let's say if rows, let's call it rows above zipped with rows below, this zip will cut the iterators, like it will take the shortest, so that is what I want. if these are all equal, basically, we're done. So row above and row below, if these are equal, then we're done. If this is the case, then return the column. Is this what we want? Yeah. Let's print something here. Found horizontal line of reflection at column col. So let's cargo run, not ruin, run the bin 13 with the inputs for day 13, the sample inputs. Yeah, it found column 4. Awesome. That is what we wanted, right? It is in here. And that is the second pattern, horizontal line. Columns to the left of. Wait. Oh, okay. I am an idiot. I call all of this. I call this thing column, but it's definitely not column. It's row. So we found this thing. The number of columns to the left, and 100 times multiplied by the number of rows above each horizontal line of reflection. That is what we found, but we were calling this column, and I guess if you are watching this and paying some attention, we're wondering, like, how could I get this so wrong? So this is not a column, this is a row. We're accessing the rows here, fine. And these are the rows above. Okay, this still makes sense. I was thinking in rows, but called the iteration thing column, but horizontal line of reflection at a row, and we are going to return row times 100. And we're gonna do the same for columns, but it's gonna be a bit. Let's do the rows first, because rows are going to be simpler. Columns are going to be more difficult, but we are gonna not multiply by 100 here, and actually we don't want to. This might fail, basically. I want this thing to fail. So let's make this an optional thing, and here return a sum of these. Okay, and I think I can do this. Yeah, look at that. And otherwise return none, because if there is no horizontal or vertical line of reflection, then, well, we should say none. And well, here we are summing these, but not very. Should I just return 0? I'm tempted to just return 0, but that shouldn't happen. But let's say if there is no horizontal or vertical line of reflection, then 0. Why not? Why not? But also let's print a message. Oops. Let's print a message in that case, because I want to know. Prints line. No line of reflection found. Okay. Okay, how do we do the columns? Because I just copied the loop, but this is not right for columns now. We had to start at 1, but not go like this. We should go until the width of the pattern. So maybe we can extract this and say this is the height, just to know what we're talking about. And this is the width of the pattern. So we're gonna do sort of the same idea, but here to have rows and columns. How are we going to do that? Well, rows above. Yeah, this thing here, each of these is nicely a vector that can be compared. So that is good to know, but rows above, rows below. You know what? I'm thinking that here, yes, we can do this. I think actually I don't know if we can do this or simply. Let's try. If we say, hey, have indices for this thing, does this work? This is already an iterator, so we can do something like this and like this. So we're gonna have like just the indices. Why can't you? Range 2 is not an iterator. The following traits. Range 2. It's a range 2. How can this not be an iterator? So what is? I guess this is only for accessing stuff, but my idea here is like, let's have just the numbers of rows. I mean, for rows it is fine. For rows it is fine. Let's sketch this out of what I want. I guess we could say, okay, go from 0 up to here, that's fine. And go from row up to whatever. We can use the height here because we already know. And this will now be numbers. We are comparing numbers, which won't work. It won't find the line that we were finding before. Yeah, no lines of reflection found. But basically, instead of comparing this, we would be comparing pattern accessed by this pattern. And now we should find, yeah, which I think is a bit simpler to think of. Yeah, I kind of like this, like to be replicated on here. So now we are going by columns. So let's actually sort of copy the same thing. This is actually rows above, rows to the left, and rows to the right. Could call it left rows and right rows, but okay. Rows to the left, yeah, it's going from this up to column, and then rows to the right is going from the column up to the width of the pattern. Okay, fine. And now we do a very similar thing. These are the indices, row above. And here is this column left and column right. Maybe I should call this thing indices or something, but I'm already calling this column, which is like sort of like an index, and I'm just calling column, so it's fine. And now this comparison will be a bit more difficult because we want to see that like it's basically going to be comparing two iterators. So how are we going to do this? Well, let's think. Yeah, we're gonna grab all the, well, iterate on over the pattern itself. So we're going to go by column, so we need to iterate all the rows of the pattern, map this into yeah, okay, we want that. What do we want for each row? I'm having trouble thinking this. We're comparing columns, so yeah, for each row we want that the character on each of those columns, the column to the left and to the right, must be equal. So here it's another all, nested all thing. So row at col left should be equal to row at col right. I don't know if I made this condition right, but let's just run it and see. Well, 205. Find a horizontal line of reflection at row 5. So that is correct for the sample. Very nice. Let's actually run with the input. Maybe let's not print this 2, but leave this other no line of reflection found, so that we know if we have screwed up in there. Oof. It didn't found some, like for some patterns it didn't found any line of reflection, so this might not be the correct answer. Let's try it anyways. Your answer is too low. Okay, so for some patterns we are not finding this. That's a bummer. And we should summarize pattern. Here I want to know when, for which pattern we are failing. Finding these patterns by by number is going to be, no, not these ones, but the ones on the input is going to be a bit difficult. So let's enumerate these things. Enumerates. Can we, yeah, we can do the conversion of converting, like inlining this function call, but not the other way around. It's like de-inline it and make it a closure again. So here we're gonna have the pattern and the index of the pattern. We're gonna summarize the pattern. No, actually the index comes first, so gonna still summarize the pattern, but we also want to let's say results, I don't know how to call it. Let's put this into this, and if result is 0, then print line. What do I want to print? Actually, let's just print the pattern. I think we can do that if we do something similar to this. So just the input split. Oh no, we have the patterns here. Yeah, but I don't want to print like the grid. I want to just print the input. So we're gonna split by this, and then give me the nth at I, and unwrap. This should exist. So let's run this. No line of reflection found. But isn't this a line of reflection, I wonder? So there's a bunch of this. There's quite a lot. This one is small. And it seems to me, well, no, this is not a line of reflection. I should bump the font size here. Oh, it's bumping everything. Can I bump just the console? Well, okay, this is fine. Where is the line of reflection in this one? So it's not this, because this is not reflected here. Is it horizontal? Or is the line... Why doesn't this count as a line of reflection? I think this should count. Like between these two rows. So maybe we did the condition wrong. Because otherwise I was thinking, no, that is the one, right? I think this is the one for here. So maybe the condition, like the endings of those loops are wrong. It also looks to be the case for this one. What about this one? Well, the last two rows are different, but the last two columns are the same. So yeah, an off by one error, I think. So in these for loops, I guess I have to just do not the -1 thing. And this sort of makes sense, right? Yeah, this actually makes sense, because the width is not a possible index. So let's say, like, oops, the first one has, for example, a height of 1, 2, 3, 4, 5, 6, 7. So the indices will go, well, from 1 up to 7, but not including 7. So the maximum will be 6. But 6 is a valid index. So so we are in this case going by rows. So the rows above will be from 0 to 5. So this, yeah, okay, yeah, it makes sense. It was just an off by 1 error, and if we run now, we have no prints of no lines of reflection. So is this the correct answer now? Yes, it was. Okay. Yeah, the off by 1 errors keep being the bane of programmers, I guess. Let's see what part 2 has to offer. Smack. You resume walking through the valley of mirror and smack, run directly into one. Hopefully nobody was watching, because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Ooh, exactly one dot or hash should be the opposite type. Ooh. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. A different reflection. What's the the old reflection line won't necessarily continue being valid after the smudge is fixed. Wow! We actually have seen one of those, right? Here's the above example again. So this example, I thought that this was a horizontal line, but then I said, oh no, because this is not here. But I guess this is the smudge. If you change this, then there will be a horizontal line. The first pattern's smudge is the top left corner. If the top left hash were instead a dot, it will now have a different horizontal line of reflection. Ooh. Okay. With the smudge in the top left corner repaired, a new horizontal line of reflection between rows 3 and 4 now exists. Row 7 has no corresponding reflected row and can be ignored. Yes. But every other row matches exactly. Now 1 matches row 6, row 2 matches 5, and row 3 matches 4. Yeah, okay. In the second pattern, the smudge can be fixed by changing the fifth symbol on row 2 from a dot to a hash. So fifth symbol on row 2. Let's look at the pattern here. Row 2. Yeah, okay, so here is if you put this. Oh wow, this is a very interesting part 2. Now the pattern has a different horizontal line of reflection between rows 1 and 2. Summarize your notes as before, but instead use the new different reflection lines. In this example, the first pattern's new horizontal line has 3 rows above it, and the second pattern's new horizontal line has 1 row above it, summarizing the value 400. In each pattern, fix the smudge and fix the difference. Find the different line of reflection. What number do you get after summarizing the new reflection lines in each pattern in your notes? Whew, that is a very interesting thing. Indeed. How are we going to do this? Well, okay, I have at least 2 ideas. One is terrible, the other not so much. The terrible one is to just brute force the hell out of this, and for every tile on each pattern, try to change the tile and see what happens. Like, see if there is a line of reflection, and if it is different from the one before. Which would be a valid solution, I guess. A horrible one, but it would be valid. The other way of doing this would be to kind of count how many differences we have seen when doing, like, considering each reflection. And so when we see only one difference, we know that if we fix that, then that was this much, and if we fix that, then there will be a reflection. That sounds actually not too hard. Let's try that. So this is summarized pattern for part 1, I guess. Yeah, we're gonna let's copy this. Just copy it without shame. Call these things answer 2. Here, print the answer 2. I'm just going to have also this in case I mess it up. Come on, Simona. So this will be summarize pattern. Yeah, I could call these things like find line of reflection or whatever, but it's like, okay, summarize pattern with smudges. Oh no, I rename it. Just say with smudges. Actually, this is a single pattern, so with smudge. So yeah, I think that this shall be pretty similar code, but a different thing that we want to do instead of asking for all. Yeah, with smudge. You don't like this because what? Oh, because we didn't rename this with a smudge, of course. Okay, let's not think about this too much. Let's just also copy the expected output for this input. So what are we going to do? Well, let's go. Here we were going through the rows and asking if they were all equal. We are not going to do that. We are going to count the differences. So let's extract it into a variable and call this thing a diff count. And we're going to say, okay, if this difference count is 1, then we found a horizontal line of well, yes, let's add these prints again. With smudge. Yes, add that. But how do we count the differences? Well, we are going to go through each row above and below, and we're going to map to the differences or some. Now let's map and do the differences and sum these things. What the hell is sum 1? Come on, that is a terrible name. 3. What a weird name. But yeah, well, I just want the normal sum. And this is going to be a U size. Okay. And now, I don't just want to ask if these things are equal, I want to iterate them. So this is a row. I want to iterate you row, and let's actually zip you with this other row, and then filter. What do I want to filter? I want to filter the ones that are different, right? So we are getting two different wait, let me think. Now we are going to iterate over each row, so we're going to find a tile, a single tile above above and a tile below. And this is inside of, wait, let me format this. We zip the two rows, and we want to count the differences, right? So we're going to filter the ones that are different. Tile above different than tile below. And we're gonna count this. And you don't want that because, one is tile above is, that is annoying. Oh, because we are, can we into iterate you? I wonder. Not really, no. It's really annoying that this is not symmetrical. Oh, but maybe if I do iter here, it will be symmetrical. Yes, it is symmetrical now. I'm happy. Questionable, but yeah. Let's see if we find some horizontal line with smudge. Oh, I ran with the actual input. I didn't mean to do that. Let's run the sample. Sample.txt. Yes, look at that. Found a horizontal line with a smudge at row 3, which is what we found here, and then one at row 1. That's great. That's promising. So let's copy the same approach here. So what we now want to do is extract this into same idea, div count. There's gonna be some repetition, but we're gonna say if this div count is 1, and now we are going to compare columns, which we already are like having iterators here. So that is not too bad. Actually, this zip is like annoyingly complicated. Like, why is this zip like this? Remember what we are doing? Like, we are comparing, things in this row with things in this row. I guess we could also well, let's leave it like that because that seemed to work. Think about going over columns now. We were going over all the rows and comparing the row on the two different columns. So can I just change this to map like this? And if they are, like, map it to booleans, if they are different, right? It's gonna be a boolean up to here. We can convert these things as usize. Oh, here we are saying all. So this actually should be mapping to a sum. And here, so we are counting over here. Okay, here we are filtering the ones that are, yeah, here we can do the same, right? We can, instead of map, we'll say filter the rows that are, yeah, how many rows differ in the in this column position, and count this. Is basically the same logic as above, but for some reason this time it was easier to do the columns than to do the rows, which is surprising, because here we are zipping this and yeah, okay, I guess. Yeah, kind of weird that this was more difficult than this one, but let's actually see. Oh, we were also always printing horizontal. This is actually vertical, but we don't know actually if this works, because in the sample we don't have vertical lines with smudges. So if we run this, we're gonna have only horizontal ones, and the answer is 400. Let's run the input. We did find some vertical lines with smudge, so let's try this number now. And it was correct. Awesome. Okay, so today's puzzle, or not today's, actually 2 days ago's puzzle was much more simpler, much easier than the combinatorial one of day 12. So yeah, lines with smudges. I think yeah, this is always like a question for me, like this should probably be an error, but not a crash, like an error to propagate up, like saying, hey dude, there is no line of reflection here, and properly handle this. The problem with like properly handle this is that we would have to accumulate those things. But okay, let's clean the unnecessary things out. If the diff count is only 1, it means like that is the single smudge, and I think it makes sense to count everything. We run this, it's fine, and it seems to run quickly enough too. So if we do a cargo build, oh look at that, well, a cargo build and then time, something like this. Same idea, but for day 13 this will fail, but now it will autocomplete. Yes, it's just nothing, 2 milliseconds, nothing, it's fine, algorithmically super fine, no need for optimization here. Okay, we don't need also these prints here, so let's remove this thing and inline this now inline this variable. Great, we don't need to enumerate, of course. Then we can get rid of this. We can even do what clippy tells us to do. Let's do the same here, inline, not enumerates, easy refactors. Yes. And now answer 1 and answer 2 are super symmetrical. That is great. This thing is fine, I think. Yeah, we can have this inferred. And summarize pattern. Let's well, yeah, summarize pattern with smudge. That is an okay name. Let's extract this actually into saying rows above and rows below. Yeah, all rows equal. Okay, yeah, nice. And this should be something like same idea, but all colors equal. Good. Rows above, rows below. I sort of want to call these things like indices instead. Wow. Indices above, indices below, or top indices, bottom indices, or something like that. But yeah, this is fine. This is this fine also? Yeah, because here we are comparing like two vectors, or yeah, things that know how to compare themselves. And here we are basically doing the same, but for using an all iterator, iterating all the rows and comparing the column of each row. So yeah, makes sense. Here, this zip thing, I think is the most sort of complex thing. So can we simplify this somehow? I'm pretty sure we should be able to. So we have a row above and a row below. That's what accessing the pattern like this gives us. And we want to know when we zip them together, when we compare one by one, how many are different. So it sort of makes sense. Yeah, the code definitely makes sense. It's just that it seems a bit arbitrarily complex. Iterating rows. For each of the indices of the row. Okay, yeah. Well, these indices of the row above and the indices of the row below are kind of like the thing with which you can access each row. Yeah. Okay. Well, let's leave it at this. And this is a similar thing where we are filtering and counting, and then adding this up to know the differences. Yes, and we need to sum everything up, right? We need to calculate all the differences because we need to be sure that the difference is only 1, because the smudge is only 1 pixel. Okay, so I'm very much okay with this solution. The only thing that I'm not terribly happy with is this 0 as a fallback for this, because like if we don't find a line of reflection, I would like to float that problem and tell us about this. So is there a nice way of doing that? Like we can make these things return options, which is fine, but then I wonder if we need to we would need to collect them before. I think we might. Like the iterator, the thing that consumes the iterator here is the sum, but there is no like optional sum. Or actually, we did see that there was a sum 1. Actually, what does this thing do? Iterates over the entire iterator and adds all the elements. Yeah, no, it's not. This is what I want. It's not like this. The items are optionals. What is it that I would like to do? It's like I want to fold these things, and if anything is none, I would like to float that up. But you know what? This is not very important. I know that for my input this works, and if the input is malformed, well, tough luck, I guess. We could make this thing return an option, but then eat those optional nuns with a filter map here, which would be the same thing. Like if we do a filter map, and look at this, there is a filter map OK from itertools, which does, what does it do? I want to learn about the itertools because it's so powerful. Okay, and transform every OK. Interesting. Okay, weird but interesting. But if we use a filter map, for instance, oh, it makes this thing go multi-lines. That is a no-no. Yeah, but why am I trying to do this? Like, it won't change the result, and if we are just going to eat the numbers, is like, okay, it's fine. Summarize pattern with smudge. This is also fine. There is, of course, some repetition between these two, but like these would be the same as this with a difference of 0, I guess. So maybe we could leave only one of the two. Yeah, could be, right? Like, that is tempting to do. If we have the pattern like this and we would say, okay, summarize the pattern with a difference of 0, would be the answer to part 1, and then the answer to part 2 would be the same thing but with a difference of 1. Kind of tempting to do that. Actually, wait, before doing this stupid refactor, which I think our check all, is it working? I think not, because I think I forgot to add the day 13 answers, which I guess is this 2, 889, 224. Oh, let's look at the advent calendar. Ooh, we are in the lava zone, and we have been on the valley between the mountains. That's awesome. But 889, 224. Okay, yes. This goes to answers txt. Great. And now we can do the refactor that we know the actual answers. So what we were writing was this, right? We're going to have a single function to summarize pattern, and it's actually going to be this thing. Instead of saying with smudge, can I say expected diff, and here instead of comparing to 1, you're going to compare with expected diff, and we get rid of this function. So does this work? Nope. We are getting now answers to part 1 in, because I'm an idiot. Whoops. Check all. And now it works. Okay. That was a simple and nice refactor. So a difference of 1 is a smudge. A difference of 0 is there is a perfect reflection. And that's great. Expected diffs. Yeah. Very good. Very, very good. And I guess now we can just inline this type definition, because we only have one usage of this. So nice seeing you, but no need to see you. It's not complaining about not converting this to. I thought that Clippy complained about this kind of thing. If we run cargo Clippy, weird. Why is it not complaining about this being a, how do you call it? A slice? Like this could be a slice like this, and usually Clippy tells us about that, but no, what's the difference there? Objective to a vector. Yeah, what is the difference there? Why can't this be? What is your problem? Cannot be known. But I mean, you're passing a reference, right? Oh, because this is very interesting. This thing, I realized now what was happening. It's like this is, the type here is like driving the inference in here. And if we put this pattern in here, well, now I think that we could do that change. Yes, now it is valid. But that's a head scratcher. Let's leave it like this. Okay, let's add all of the things and commit. Add a solution for day 13. And this was simple enough. I guess we can, before leaving, we can make a little toilets thumbnail. So this will be day 13. Mirror reflections. How was the name of the thing again? Point of incidence. What the hell did this have to do with anything? I thought that part 2 was going to be much more complicated, to be honest, with all of the patterns that we had, but it was not too bad. Mirror reflections. Let's see how this. Not very inspired, right? Mirrors with smudges. Smudged mirrors. Yeah, that is a word. It's actually a word. Smudged. Smudged. Yeah, it is what. So smudged mirrors. Let's make this smaller. Let's clear the thing. Oh, look at those colors. Those are nice colors. And let's put the code here to the right. I think at some point I will start cutting out this making of thumbnails, but look at this code. It almost fits into like a single screen, just 50 something lines of code. That's awesome. That is, well, that was day 13. Surprisingly simple compared to the previous day. And if you haven't, thanks for watching. And as usual, I want to have like a closing phrase, but I never get used to saying like, as always, thanks for watching. But yeah, that's what I want to say. If you have been watching, thanks for doing so, and see you next time. Bye.